Problem 1 is, actually I'm going to leave you with problem 1. Problem 2, pebble dropped into a deep well, is object falls, the sound comes back up. Similar to the gunshot, and then you hear the sound of it, except now the distance traveled here is under the influence of acceleration due to gravity. The velocity and the distance traveled up here is velocity of sound, which would be 340 meters per second, and so the distance traveled would be equal to velocity times whatever time it took for it to come up. So we've got the distance down, which is VIT plus 1/2 GT squared. Initial velocity would be 0 if you're dropping it, so the distance down would be 1/2 GT squared, and the distance up, which would be the same distance, would be the velocity of sound times however much time it took to come back up. And I believe in that problem we were told there was a total time of 15 seconds, so we can define this amount of time as 15 minus t. And all of a sudden we're back in our quadratic. 1/2 GT squared is equal to 15V minus VT. V is a known quantity, G is a known quantity, T becomes the unknown quantity, and it's solved using the quadratic. Problem 3, an object is thrown upwards, and at the same time another object is thrown downwards, both with the same velocity. At the end of a time interval of 1 second, what is the total distance separating them? Well, if you look at the distance traveled upwards, it would be equal to the initial velocity times time minus 1/2 GT squared, because the velocity vector and the acceleration due to gravity vector are working in opposite directions, and so if we call that positive, that must be minus. So that'll tell you the distance the ball travels upwards in 1 second. Going downwards, however, the equation becomes VIT plus 1/2 GT squared, because in this case the velocity vector and the gravity vector are acting in the same direction. And so you would add them together, and that would give you a different distance, and then you could just find the total distance between them after finding that. The fourth problem is the famous train problem once again, except now we have initial velocity is equal to 0, and they're accelerating towards each other. And so the distance this would travel would of course be, and they're going north and south, so we'll go ahead and use y for our displacement, is VIT plus 1/2 AT squared, VI being ignored. The distance this would travel would be 1/2 AT squared. And so the total distance traveled would be 1/2 the sum of the accelerations times t squared. And so you sum the accelerations, you got total distance, determine how much time it takes for the entire event to take place before they hit, and then go back and use that time to find out how far the one car travels or how far the other car travels.